Hello viewers, welcome to Construction Safety Man channel. I am Prithvi. In a recent video, one of the viewers requested for a video on Hira and SWMS. So today, let me try to explain this topic. I thank at Safar AZ Sheikh 3279 for this suggestion. However, I will be bifurcating this topic into two videos instead of one, as the topic is vast and would need considerable understanding. I'll be speaking about Hira in this video and SWMS in the next one. We will also try and develop a Hira for a basic activity so that we understand how Hira is developed. However, we should remember that basic and complex activities are linked with each other in these topics, such as hazard, risk, and control measures. HIRA is an abbreviation of hazard identification and risk assessment, whereas SWMS is an abbreviation of safe work method statement. Hazard identification and risk assessment, or HIRA, is a process used by safety and risk management professionals to recognize hazard, evaluate its consequence, impact, and recommend control measures. Now, the process is fairly simple for HIRA. However, it needs considerable experience and practice to master it. I do not claim of being such a master of Hira process, but I will try my best to explain Hira process in the simplest possible way. I have referred the below standards for preparation of this video session. Viewers too can read the document and understand the topic of Hira on their own as well. First one, Indian Standard 15656 2006, Hazard Identification and Risk Analysis, Code of Practice. Second one, International Standard ISO 45001 2018, Occupational Health and Safety Management Systems, requirements with guidance for use. Did you know that the IS code 15656 is intended for the areas of chemical plant safety? However, we will draw few portion of this code to understand about HIRA process in construction operations. Before we go into understanding what is HIRA and how do we develop one, we need to know some basic definitions. These are more like my understanding of these terms rather than an actual textbook definition. So please bear with me. And also some ground rules about things that could help in developing a good HIRA, which I have picked over years and also taught to me by my managers and the experience that I have got over the years. They are basic event, which is a faulty event that is sufficiently basic that no further development is necessary. And for the reason of keeping this discussion simple, we will assume most of the hazards as basic and not complex in nature. However, I will try to link few hazards with other sub-activities to explain its complex nature during the example. Work activities. They are steps, processes, and physical action that form a construction operation. Example, concreting, shuttering, plastering. Then we have subsidiary activities or sub-activities. This is a division of work activity. It is broken down into small basic activities and when combined in a particular order forms work activity. For example, if concreting is a work activity, Sub-activities of concreting can be mixing of concrete by hand, by machine, transit mixer movement within project premises, positioning and setting up of concrete pump or boom placer, pumping of concrete, pouring of concrete to its final location, etc. I might have left few steps here, but hope you understand the final intention. That is, you are breaking a complex work activity into simpler portions so that we are able to recognize hazards easily and propose control measures to these hazards. Then we have hazard. It is an occurrence, phenomenon, or source that has the potential to cause damage, harm, or ill health to workers on a project site. Risk. It is an effect of uncertainty. Risk is often represented as combination of likelihood of occurrence and severity of occurrence. It is common to mix up between hazard and risk. So these are few examples of hazards and risk. Unprotected leading edge is a hazard, whereas fall from height is a risk. Exposed electrical cable is a hazard, whereas electrical shock, electrocution are risks. Thus, let us be clear on what is a hazard and what is a risk. This is very important for Hira as well as safety inspections. Likelihood of risk occurrence is the possibility of potential hazard occurrence in a given time frame. Based on historical knowledge of industry, organizational activities, normally likelihood is represented as high, medium, and low based on how often a hazard can occur in a construction project. Then we have consequence of occurrence. It is the severity of the potential negative effect in the event of hazard occurrence. Basically, it means in the event the hazard occurs and all the things that can go bad can happen, what will be the impact of a worst case consequence? Now, for Hira of construction activities, we consider worst case consequence and not the best case consequence. This is normally rated as first aid wound, injury without lost time injury, single fatality, catastrophic fatalities. Lower rating at first aid injury and highest rating at the catastrophic fatalities. Now we have the definition of worst case consequence. It is a conservative high estimate of the consequence of the most severe accident occurred for a particular hazard. Accident, it is an unplanned event that has resulted in injury or ill health. Then we have definition of lost time injury is bodily injury by reason of which the person injured is prevented from working for a period of 48 hours or more immediately following the accident. Then we have to understand about risk level. It is the combination of likelihood of occurrence and consequence of occurrence. It is normally represented as low, high, or medium and or in a numerical value. Control measures. These are the measures proposed by the Hira team to reduce or mitigate risk level of a particular hazard. Then we have additional control measures. These are the measures proposed by the Hira team in addition to the existing control measures to reduce or mitigate risk level of a particular hazard. These measures are normally proposed where risk level is not reduced to acceptable level. What is acceptable level? We have a definition called as ALARP. It is an abbreviation for as low as reasonably possible or as low as reasonably practicable. Hierarchy of control is one more definition that we have to know. It is a particular sequence of control measure proposal. that must be applied in the hierarchy as proposed. Below are the best way to propose it, which are elimination of hazard. As the name suggests, here we are trying to eliminate the hazard altogether. However, this is a difficult task in practice and mostly has a very small window in the entire project time frame where we can apply such control measures. But the effect of such control measures will result in complete removal of a particular hazard type from the construction sites. The scope of such implementation is also mostly limited to design phase of a construction project. Substitution of hazard. Here we are substituting one high risk hazard from another low risk hazard. Most common example we get is change of a particular riskier chemical with a low risk chemical that is lower than the latter. Control of hazard, which includes engineering control and administrative control. These are implementation of engineering and administrative measures to reduce the likelihood of occurrence of a particular hazard. Then we have something called as personal protective equipment. This should be the least favored method for hazard occurrence control, but instead gets used as the most favored method in most construction project sites. Irony. This is introduction of protective gears to the workers to reduce impact in the event of any hazard resulting in an incident. With this, we have understood all the necessary definition for Hira process. Let us build some ground rules with which we should work on Hira document. Hira should always be performed with a team and never should be done individually. Hira team must always include persons who have hands-on experience as to how a work or activity is performed and sequenced. Persons who have experience in safety requirements and implementation. Persons who know about the investment process and can make decisions on budget allocation for safety requirements. Persons who deal with procurement and persons who know about plant and equipment that can support in activity progress and also improve safety simultaneously. Hira team should always get all the necessary reports and documents before start of Hira process. Good for construction drawings, work method statement, past accident records and its analysis, original equipment manufacturer manuals, safety data sheets, lifting plans, and any other necessary documentation. Hira team should also be aware of the project schedule and timeline and should remember that risk management is done to work safely, not just implement safety. Safety must always accompany work progress and vice versa. The sub-activity must be sequenced in the same way as work method statement of a particular activity. While recognizing hazards, try to cover all phases of hazard. A simple tool that I personally use is 3M and PE, which stands for the first M stands for material related hazards, the second M stands for machinery related hazards, the third M stands for men or worker related hazards, P stands for work procedure or process related hazards, E stands for work environment related hazards. While you propose control measures, always propose safe failures. That is, in a case when things go wrong. Where exactly is it designed to go wrong? With least impact to workers' life? One example is to define a no access area for swing portion of crane and barricading it while lifting material using crane. If in the case loads fall while lifting, yes, the load will fall to ground and there will be damage to property. But since the area is barricaded and declared as no access zone, no worker will be harmed as the worker and the fall of material will not coincide. That is, the occurrence and likelihood does not happen at the same time. Then we have to ensure control measures are only proposed to reduce the likelihood of risk occurrence and will never have an impact on consequence of risk occurrence. Control measures must be proposed for individual hazards and not be mixed up or jumbled up with many hazards. While proposing control measures, always follow hierarchy of control and ensure that hazard occurrence is reduced to alarm as low as reasonably practicable level. Each control measure must be assigned to a person responsible for its implementation by name in the Hira register. Control measures can be separately listed and can be assigned a letter and number for each of them respectively. And these alphanumericals can be mentioned in the Hira register to simplify the Hira process. For example, control measures related to fall from height. Not constructing high-rise building at all can be A1. Restricting building height below 15 meters can be A2. Edge protection by hard barricade can be A3. Secondary net protection can be A4. Cocoon net protection can be A5. Work permit for height works can be A6. Ensuring only height work trained workers can be A7. Personal fall protection device such as lifeline, safety harness, fall arresters can be A8. Please note that I am following the hierarchy of control. As already mentioned, these numbers can be mentioned in the control measures section of HIRA. Now, as we know the definitions and also have defined various ground rules, let us try and develop a HIRA for a minor activity. We will not stick to the tradition of tiger in the cage and tiger outside the cage example. The most risk assessment trainings use this. Let us develop an actual HIRA register. We have few headers as row that are serial number. Here we mention reference number for the activity. Then we have activity. In this it will be block work. Sub activities, which is very straightforward. Let us consider laying of block and mortar as one of the sub activity. Once the sub activity is mentioned, we will use 3M and PE to list all the probable hazards of sub activities. That is, material, loose blocks as hazard, machinery, let us take nil, men working at exposed edges as hazard, procedure, poor scaffold as hazard, environment, poor illumination as hazard. For each hazard, we will mention worst case consequence risk. That is again, material, hazard is loose blocks and risk is fall of material. Machinery, hazard is nothing, so nothing risk. Men working at exposed height is the hazard and risk is fall from height. Procedure, hazard is poor scaffold, risk is collapse of scaffold. Environment, poor illumination is the hazard, So risk is trip and fall on the same level or fall from height. After which we will mention all existing control measures, and then we will rate the likelihood of occurrence and consequence of occurrence considering the existing control measures. Kindly remember that control measures affect only the likelihood and not the consequence. So, if a particular hazard has a worst case consequence of fatality, then this rating will remain same even after the existing control measures are there. We use the risk rating chart or risk matrix to find the risk level based on rating of likelihood and consequence. That is, for hazard loose block and the risk fall of material, assuming basic existing control measures, the likelihood will be possible rated around 3 and consequence will be major rated around 4. Here we multiply 3 times 4, which will give us 12. In the matrix, 12 is an issue and color coded as orange. If the risk level after existing control measure is not in acceptable level, then additional control measures are proposed as per hierarchy of control. After additional control measures, the likelihood and consequence is re-evaluated using risk matrix. Remember, consequence will still remain same. Only likelihood can be changed. And new risk rating is mentioned. Here we will try to bring the risk level to acceptable level by additional control measures, and once that is done, names of concerned team members who are responsible for implementation is mentioned in action by. Hope you understood the entire concept of Hira, and also you will be able to implement these things in a better way at your own project sites. Now we will have to also understand that individual hazards are sometimes linked. For the same example, when we take block work at height on an end face of the building, we'll have to understand that multiple floor working will lead to risk of fall of material on people who are working in the lower floors. So this hazard is linked to other activities. So this linkage can only be understood by people who have experience in the construction project. So I again suggest that Hira should always be done with a team and never alone. Hope you enjoyed this Hira video. I'll be coming back with SWMS video maybe next week, and hope you will be able to implement these in your project site and maybe save lives. Thanks for watching. Please do like and share the video so that other safety professionals can view the channel. And also do not forget to subscribe the channel and hit the bell icon for latest updates.